Hello. Welcome to a brief video on conversion of fractions to decimals using techniques in Vedic mathematics. Let us go together.
Hello everyone. Today in the chapter Auxiliary Fractions, we will discuss Vedic techniques to convert some fractions into decimals within seconds. You will be astonished to see the speed provided by Vedic techniques used here. Suppose you have a fraction like this, 5 by 21 or 5 by 29, 6 by 38, 7 by 48. Such fractions you can convert into decimals using Vedic techniques within seconds, within very few seconds. The techniques are useful when a particular fraction satisfies the following conditions. When a fraction where numerator is less than denominator consists of 2 or 3 digits, and finally last digit of denominator ends with 1, 6, 7, 8 and 9. Don't worry here. Suppose a divisor or denominator ends with 2, 3, 4, 5 and 7. You can convert to 1, 6, 7, 8 or 9 by multiplying with a proper number. Let us recollect our conditions first. A fraction like 5 by 29 satisfies the conditions. Numerator less than denominator, 5 is less than 29. Divisor is small, that is consists of 2 to 3 digits, and the last digit of the divisor ends with 9. 6 by 38. You can use our techniques, and suppose 4 by 21, etc. You can use our techniques. I will start explaining with an example. Suppose you have a fraction 5 by 29. We will discuss the steps. So first step, just add 1 to the denominator to make it 5 by 30. Second step, remove 0 from the denominator by writing it as 0.5 by 3. The answer is not finally 0.5 by 3 or 0.166. It is not that way, but we carry out step by step division like this. So 0.5 by 3 is our fraction now. We will carry out step by step division as follows. 0. So we will divide 5 by 3. 5 by 3 quotient is 1, remainder is 2. Quotient is written on top like this, and remainder is written bottom. So our next number for division is 21. So we will divide 21 again with 3. Quotient is 7, remainder is 0. Our next number is 07, that is 7. So 7 by 3, quotient is 2, remainder is 1. Our next number is 12. So 12 by 3, 3 4s are, remainder is 0, and 3 1s are 3, remainder is 1, and the process can be continued further to any number of places. We will take another example. Suppose 88 by 89. Please try to remember the steps. We will add 1 to the denominator to make it 88 by 90. Step 2, remove the 0 in the denominator by writing it as 8.8 by 9. So our number for our process is 8.8 by 9. Since the ratio we all know 88 by 89 is less than 1, so 0 point, we will take it as 88 and divide by 9. So 9 9s are 81. Remainder is 7. Now our next number is 79. 79 by 9. 9 8s are 72. Remainder is 7. Again 9 8s are 72. Remainder is 6. Now 68 by 7. 9 7s are 63. Remainder is 5. 9 6 are 54. Remainder is 3. So the process can be continued to any number of places. So our third example, let's take 3 by 13. Hey, now how do you proceed? Think for a while, my friends. It's nothing, just multiply both numerator as well as denominator with 3 to get it as 9 by 39. We will carry out the same steps as we did before. We will write it as 9 by 40. And finally 0.9 by 4. So this is the fraction we are going to focus on. 0.9 by 4 equals 0.9 by 4. Quotient is 2, remainder is 1. Now 12 is our next number. 3 is quotient, remainder is 0. And finally 3 by 4. 0 is quotient, 3 is our remainder, and the process can be extended. Well, these are additional examples for your practice. Consider third example. We have 1 by 7 here, and we multiply numerator as well as denominator with 7. 3 by 17, the same way, 3 into 7 and 17 into 7. 5 by 6.9. Now see here, 5 by 6.9 is nothing but 50 by 69. And like before, we will do it this way. 50 by 70, that is 5 by 7, and we will carry out step by step division. 0 point. Okay, let's focus on 5 by 6.9. It's nothing but 50 by 69. So write it as 5 into 5 by 69 into 10. Now 5 by 69 is our fraction, and we'll do as we did before, and finally multiply that number with 10 to get our desired answer. Now we will focus on the fractions where the divisors end with 1. Suppose you have a fraction like this, 13 by 31, or 1 by 21, or 72 by 81, etc, etc. Let me explain you. Suppose you have a fraction 4 by 21. Focus here. Now how do we do this? Actually, we'll subtract 1 from both numerator as well as denominator. In the previous case we just added 1 to the denominator. Here we will subtract 1 from both numerator as well as denominator to make it 3 by 20, which can be further written as 0.3 by 2. This is our second step. We should remove 0 from the denominator and write it as 0.3 by 2. The answer is not finally 0.15, but we will carry out step by step division as follows. So we will consider it as not 0.3 but just as 3. So 3 by 2. 2 and the again 1. Now the second step is very much important. We will just subtract 9 from the digits written on top, that is from this one. So 9 minus 1, 8. Now our next number is 1, 8, 18. Again we will divide by 2 to get 9 and 0. We will subtract this number from 9 to get 0 again. Now we will do 0 by 2. Nothing but 0 and 0. That is both quotient and remainder are 0. Again we will subtract 0 from 9. Now our next number is 0, 9, that is 9 by 2. These two digits will be taken as the next number for division. So 2 4s are 8, 1. Again subtract 4 from 9 to get 5. Now our next number is 1, 5, 15. And again 7, 1, 9 minus 7, 2. Our next number is 1, 2, 12. 2 6 are 12, 0, 3, and the process can be continued in the same way. So our example 2, 7 by 111. First step, subtract 1 both from numerator as well as denominator. Step 2, take 0 from denominator by writing it as 0.6 by 11. Now this is our required fraction, and we will carry out step by step division as follows. 0.6 by 11 equals 0. So 6 by 11 is our fraction now. 0, that means 0 is quotient and 6 is remainder. Now we will subtract 0 from 9, that is 9 itself. Now 69, 6 and 9. 69 is our next dividend. So 69 by 11, that is 11 6. 11 6 are, and 3 is our remainder. And again we will subtract 6 from 9 to get it as 3. So 33 is our next number. So 33 by 11, that is 11 3s are, and this is our quotient and remainder is 0. Again subtract 3 from 9 to make it 6. And the process can be continued. Well, these are additional examples for your practice again. 3 by 13. In the before case, we multiplied both numerator as well as denominator with 3. Alternatively, here what we can do is 3 by 13 will multiply both numerator and denominator with 7 to make it as 21 by 91. and we can repeat the same steps. Before case we did it as 9 by 39. Either way you will reach your final answer. And 1 by 7 we multiplied with 7 for both numerator and denominator. Alternatively, what we can do here is we will multiply both numerator and denominator with 3 to get it as 3 by 21, and we will repeat the same steps and we can reach our desired answer. Take the 7 examples, practice until you attain your best speed. Thank you. Once we are clear with the divisors ending with 1 and 9, divisors ending with 8, 7 and 6 is never a big matter for us all. So here we will discuss like the numbers such as 1 by 18, 5 by 28, 4 by 38, 7 by 78, etc., etc. So let's start our process with a fine example. Let's take 5 by 28. Here we'll add 2 to the denominator to get it as 5 by 30. And second step, remove 0 from the denominator to write it as 0.5 by 3. We'll again carry out the step by step division, but this is a bit different from the previous ones. Focus here, you'll understand. So 5 by 3, naturally 5 by 3 quotient is 1, remainder is 2. What is different here is from the previous ones, it's not 21. 21 is not our next number. 1 plus 21 is our next number. That is 21 is the base dividend added with 1. So 22 is our next number. So we will do 22 divided by 3. 3 sevens are, remainder is 1. Now 17 is our base dividend, and we'll add it to 7. That means the same digit again to get it as 24. So 24 is our next dividend. 24 by 3, 3 8s are, and the remainder is 0. Now 8 plus 8, 16 is our next dividend. 3 5s are, 3 1s are, and the process can be extended. Well, our second example, 71 by 88. That means this is 71 by 90. That means 7.1 by 9. And we'll carry out a step by step division. 7.1 by 9 equals 0.9 7 is 63. 8 is a remainder, and then 87 plus 7, 94 is our next number to be divided by 9. We'll take 10 actually, not 9. It doesn't create any problem. So our next number is not 410. Wrong. What we did in the previous case is 80 plus 7. That is 87 is our base dividend before. In a similar fashion, 410 is not our base dividend, but 40 plus 10, 50 is our base dividend, which will get added to 10 So 60 is our final dividend. 60 by 9. So 9 6 are 54. 6 is again remainder. 66 plus 6, 72 is our next dividend to be divided by 9. So 8 0, and we can continue the process. See here, we have 10, 0 gets retained, 1 will get carried to 7 like we did in multiplication to obtain our final answer 8 0 6 8 dot 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 dot. That's it. Few more examples for your practice again. Now let's focus on divisors ending with 7. Let's take one example. 5 by 27. Like we did before, now we'll add 3 to the denominator and write it as 5 by 30. Then 0.5 by 3. Come on, let's carry out step by step division as follows. Five by 3, that is 0.1 2. Okay, now 21 is not our final dividend. Our 21 is only our base dividend. 21 plus 1 into 2 is our final dividend. That means 1, the digit here, multiplied with 2, added to 21. So 21 plus 2, 23 is our next dividend. So 23 by 3, 3 7 are 21, 2. Again 27 is not our final dividend. 27 is only our base dividend, which when multiplied, 7 multiplied by 2, 14 added to 27, giving you 41 by 3. Now 3 13s are 39. Again we have 2. Now like before, what we do here is 13 2s are 26, 13 added to 26. Our base dividend is again not 213, not 213, but it is 20 plus 13, that is 43, which when multiplied by, which when added with 26 will give you 59. 59 by 3 now. So 3 19s are 57 and 2 is our remainder again. And the process can be extended. By further calculation you will find that it will be like this. Now we will stop here and finally compute our final answer. That is 1 is retained, 3 gets added to 25, 28, 8 is retained, again 2 is added here, 21, again 1 is retained, 2 is added, 15, 5 is retained, 1 is added, 8, 1. So 0.185181 is our final answer. Yep. Now take these examples, solve them and try to improve your speed. Alright, now let's shift our attention to divisors ending with 6. For example, let's take 6 by 76. We'll add 4 to the denominator, write it as 6 by 80, and finally 0.6 by 8. Now we'll carry out step by step division. So 0.6 by 8, that means quotient is 0, the remainder is 6. 60 plus 0 into 3 is our final dividend, which again turns out to be 60. So 60 is our next dividend. 8 7s are 56, 4. 47 is not our final dividend, 47 is only our base dividend. 47 plus 7 into 3. 47 plus 21, 68 is our final dividend now. So 68 by 8, 8 8s are 64, remainder is 4. So now 8 into 3, 48 plus 8 into 3 is our final dividend now. 48 plus 24, now you know 72. 72 is our final dividend. 8 9s are 72, 0. And the process is naturally continued. So our second example, 7 by 26, 7 by 30, finally 0.7 by 3, 0.2, 12 plus 2 into 3, 12 plus 6 18, 3 6 are 18, 0, 6 plus 6 into 3, again 18, 24, 3 8s are 24, 0, 8 plus 8 into 3, 24 plus 8 32, 3 10s are 3 2s are, and it can be extended. So 0.26 9 dot 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 is our answer. So recollect what you have done till now. Divisors ending with 1, 9, 6, 7, 8. I hope you must be perfect with divisors ending with 9 till now and 1. And if you have 8, just because 8 is 9 minus 1, every time you get your base dividend, you take, you'll add 1, you'll add the number itself and take it as final dividend. Now 7, simply because 7 is 9 minus 2, you'll take your base dividend and add it to the number when multiplied by 2. And 6, similarly 9 minus 3 is 6. So every time you'll multiply the digit written on top with 3 and add it to base dividend to get your final answer. Now what if the divisors end with 2, 3, 4 or 5? Try to multiply with the smallest number possible and definitely you will reach your answer. So suppose a divisor ends with 2, then we'll multiply it with 3 to make it as a divisor ending with 6. That means into 3, then 3 into 2 to make again a number ending with 6. And 4, the smallest number is of course 2, so we'll multiply with 2 to make it a divisor ending with 8. And finally, if we have 5, multiply with 2 to get your desired result. Suppose we have 13 by 235. It is simply 26 by 470. I mean, multiplying both numerator as well as denominator with 2. So 2.6 by 47. So 26 by 47 into 1 by 10. Now we know how to convert into decimal number when the divisor ends with 7. So 26 by 47, you can write it in decimal form and move one digit to the left, I mean 1 point to the left, and you will obtain your final answer. So we have in this way 2, 3, 4 and 5. 2 you multiply with 3, the divisor naturally ends with 6. So let me make a table for you. Multiply with 3, and 3 you multiply with 2, 4 you multiply with 2 again to make a divisor ending with 8, and finally 5 multiply with 2. Suppose 13 by 34. Think for a while, what will you do? It's nothing, just multiply with 2 both on numerator and denominator and make it as 26 by 68. And you know how to solve, I mean how to convert into a decimal number when a divisor ends with 8, and follow the steps that we did before. Thank you. Finally, I suggest you to be patient till the last and practice these 10 final examples. If you attain mastery over the subject, you will finally understand, I mean you can have great fun and have great advantage over others when writing a competitive exam, or maybe you can stun your friend with your amazing speed. I mean, within seconds, just imagine how you can solve these fractions. Thanks for being with us. Thank you very much.
I hope you enjoyed the video and learnt about conversion of fractions to decimals using techniques in Vedic mathematics. Thanks for being with us.